Hello, guys. It's Artem here, your main host of the event. I also have Tim from Immunefi side, and we have Green and Stacy from the Fuel side. Today we will be discussing. Today is another technical walkthrough, and today we will be discussing gas, wallets, and block explorer for Fuel network. Um, I think we will start in about. Hey, Luis. We also have Luis from Fuel side also. I think we will start in about 3 minutes. So we'll wait a little bit until everybody joins, and maybe guys from Fuel team, you can maybe introduce yourself a little bit while we are waiting for other people to join us.
Yep, for sure. I can go first then. Yeah, I'm Luis Estacio, and working in Fuel. I started working on the TS SDK already on the front end projects, and right now working as the engineer manager for the Edge. And I'm going to be talking about the Explorer current life that we have, also the wallet, and yeah, I think a little bit about the playground also, just for to show to you guys. Will be probably a quick presentation, but enough for you guys to have the context here.
Okay, yeah, I am Green, team lead of client team, and today I will describe how gas model works, like for what we charge user, how gas price can change, what is steep, how it's used, and other aspects of gas pricing.
Yeah, I'm also Luis. I will be helping you guys more on the support side. So if you have any questions, just shoot it. I would try to answer all of you. And also in the final part, we will have a section for specific for questions. And then yeah, I will try my best to answer all of you.
Thank you for the introduction, guys. And yeah, while we are waiting for more people to join, let me quickly cover the basics of the Fuel Network Attackathon. So we'll have 1.3 million of the maximal bounty. We'll have 500,600 USD in the vault. The Attackathon will start on 17th of June and it will end on the 22nd of July. All the rewards will be paid in USDC. It will be traced by Immunefi. Also, if you get a valid bug report and you want to get a payout, you'll need to pass the KYC. And we have an impressive 100,000 lines of code to actually look through and to find vulnerabilities in. Okay, so it's 1 minute more. So yeah, guys, I think you can now start your presentation. Please go live.
Okay, can you see it?
Yep.
Cool. Okay, so yeah, I think we can start with gas pricing. Yeah, like first of all, yeah, um, for people who attended the previous call, I mentioned that we have fuel specification repository. So that's repository is main source of truth regarding how protocol works. Maybe not all aspects are mentioned there. So if something is not clear, like if you see that code works in a way that is not described here and you think it is important, you can create an issue and we will modify specification to be more clear on that part. So specification itself contains rules regarding transaction validity by the protocol holder. And part of those, transaction validity means that it's something that it is a set of stateless rules the transaction should fulfill. Like, for example, that your transaction doesn't use any fields that you don't need to use. In terms of, like, we have different types of transaction, and for each transaction, for example, create transaction, if we'll go to create transaction, who knows where it is? It's protocol, we need types, transaction format, transaction. Yeah, as an example, we have script transaction, create transaction, and for example, script transaction contains script field and script data field, and create transaction doesn't have those fields. Because the main purpose of create transaction is to deploy your smart contract on the network, and because you can't run any script during deployment, we don't need those fields. And yeah, here's some basic rules. Most of transaction has the same set of rules, but some of them has some unique rules, depend on their context and how they're used. So yeah, transaction should fulfill those rules. And if we'll go deeper, here is like more details regarding, like, yeah, basic checks from transaction format. You can find them here, plus some additional checks regarding TXOs, their limitations, etc. And one of them is let you have sufficient balance to do any operations that you mentioned inside of your transaction. Because transaction contains inputs and outputs, without execution, we already can calculate desired amount of tokens what you need to have to be able to fulfill your outputs. Let's say if you have one input where you have input coin that gives you 100 some tokens, and you want to send them to someone else, you need to have you need to have a corresponding output with less or equal number of tokens from amount of tokens from your input. So, for example, if your input has 100 tokens, your output should have 100 and less. And the same applies for base asset. But for base asset, we also the same rule applies to base asset. And for base asset, and base asset also is used to pay for transaction fee. So in the case of your rollup, it will be Ethereum, but any rollup can decide their own base asset ID. So yeah, base asset ID is configurable, and yeah, for each rollup it will be unique. Or as I said, for fuel rollup it will be Ethereum. And yeah, we have the same model, gas model, like any other chain with execution. Some operations on chain has its value. In the case of fuel transactions, because we have predicates, and predicates, it also executable, it's stateless executable code that you can run without accessing to storage, but it's still something what you need to run. Because of that, each predicate has, maybe let's go to view VM just to see the definition of transaction. Like, go QTX, SFC, transaction, types, and here input, and coin, for example. So if you look into definition of input coin, we can see that here we have a predicate, like it's script what we need to run, predicates data. It's some data what will be passed to predicate, which you will run, and predicate gas used. So because predicates is something what we need to execute, it also should have its own limit of how many execution should be done to be able to validate that predicate. And since predicate doesn't have access to any state, predicate the gas used by predicate is deterministic. So anyone should be able to estimate predicate, and that value should be the same regardless of any context. So yeah, what it gives to us. When user submits transaction to blockchain, he needs to estimate that predicate. He can estimate it on chain, like he can estimate it locally. So if you're using Rust, you just can, transaction itself has estimate predicate function. But if you're using TypeScript SDK, you need to send a request to any RPC endpoint to estimate transaction for you. Like view core provides an endpoint. Rates. Let's go to maybe let's go to actual definition. And somewhere here, but I don't remember where. Okay, it should be here. Yeah, GraphQL API provides estimate predicates endpoint where you can send your transaction text encoded. And yeah, at the end it will return your transaction back with estimated predicates. Coming back to predicate itself. Predicates, it's one of aspects what we will charge user. So, or of course, if you send script transaction, we will charge you for execution of your script. But also, almost each chargeable transaction that contains inputs, also may contain inputs with predicates. So for each predicate we will charge. If you have 10 predicate, each of them should have that field, and we will charge you cumulatively. So if we'll come back to, or if we'll go back to specification, here you can see we have min gas definition and max gas definition. So min gas, it's like below the description. What is it? Like it is here. But let's go right now here. It is something that it is minimal amount of gas that your transaction will consume without touching any state on blockchain. So it is combination of size of your transaction. So for each byte of your transaction, we will charge 63 gas. Again, like it's not gas and price are different things. So we will charge 63 gas. Plus, we will charge some for something for some additional information here. So what is included? Each transaction so to execute each transaction, we need to initialize VM. So VM initialization has its own cost. It was benchmarked, and you can find information regarding prices of any operations and opcodes in the specification. So we have chain configuration repository that contains specifications for different networks. It is dev cluster. You don't have access to that. It's just for us. Right now that one is testnet, but later here we'll have also configuration for mainnet and local, just for people who want to start local network. And there is an example of how configuration can look like. So if we'll go to chain config, you can find here gas cost. So yeah, it is price of each opcode, and not only opcodes in the network. So you can see that basic operations are very cheap, and operations that somehow will touch storage or crypto or some curves are expensive. And some of operations, they also depend on the input. for example, if you will try to calculate a hash or something, it has base cost, like just calling of that opcode, plus for each 3 bytes, we will charge one gas, additional one gas. It's like an example. And here we can find VM initialization. So currently, current DevNet, charges for VM initialization a lot, like 5 million gas, if we look into that value. But it will change soon. Like we did that because our code was not super optimized for some edge cases, but we already fixed that. And in I think 3-4 days, we will update testnet to use new optimized VM initialization. And instead of 5 million gas, it will cost 61 gas. So here's an example what we will charge you for. Plus, because your transaction has its size, it also affects initialization. Currently here we just charge for the worst case, but later, actually I think we can go into fuel core because it's already was released. Here, local testnet, chain config. It is local testnet for people who will start fuel core locally. And here we already have updated gas prices. After update, we will charge 61 gas as a base, just for VM initialization, plus for each 113 bytes of your transaction, we will charge 1 gas. So if your transaction will be 1,000, we will additionally charge around 9 gas. It's an example of gas prices, how they look like, where we store them. Here you can see that we charge for VM initialization, we charge for some metadata that should be calculated. For example, in the case of create transaction, we will charge for contract ID calculation because it requires creation of Merkle tree, many hashes, etc. Sometimes it can be very expensive, so we also charge for that. But if your contracts are small, you will pay nothing almost. The same for storage slots. Like when you create your contract, you already can have some predefined storage slots there. Again, if you don't have any, or you have only several storage slots, it will be cheap. But if not, it will be more expensive. The same like transaction ID, we calculate transaction ID once, and after it is cached, and we reuse it everywhere in the code base to identify your transaction. So here, we just charge. It's not. It's not for transaction ID. It's for contract ID. All those free calculations, they are related to contract ID. And here we will charge additional for transaction ID. And here also metadata for different other types. In the case of script, we don't have any metadata. We don't need charge for that. What else we have? So VM initialization, some metadata that we calculate once, and later it will be used everywhere during validation of your transaction. And we have that one. I guess there is problem with names here. Here is that function. Where is it? Okay, that one is not defined. I guess we need to fix that in specification. But if we will go to code base itself, it's estimate, like fuel VM, fuel TX, transaction fee. Here we have rules defined regarding fee calculation, and it includes also mean gas calculation. So everything that was mentioned in specification also is here. And you can see we have, gas used by metadata, as I mentioned, gas used by VM, and gas used by inputs. So gas used by inputs is defined here. So yeah, we just iterate over all inputs, and let's say if you have point predicate or message point predicate, it means that you have predicate what we need to execute. Then we will charge gas related to predicate execution. And because predicate execution also requires VM initialization, yeah, it means that we also will charge for VM initialization, for predicate ID calculation, again, just to verify ownership center. So yeah, like here you can see all rules regarding for all heavy operations that are required to validate your transaction. So we charge for them. Yeah, also we charge for recovery of public key from signatures if you're using sign coins, like any recovery what is supported. So all of that defines minimal gas that your transaction will consume. And max gas, it is minimal gas plus some additional dynamic data. For example, like during previous call, we discussed that witnesses, witness is a malleable field. Malleable means that it can change during life cycle of your transaction. And anyone can specify witness limit for your transaction, like its limit or how big witness can be. So it's like for the worst possible case, and minimal gas includes only current size of witness, so we only charge for actual bytes. And in the case of max gas, we charge for the worst possible scenario. Not charge, we just calculate it for the worst possible scenario. Plus, in the case of script transaction, max gas also includes script gas limit. So if we'll go to script transaction, here you can see that script implements chargeable trade, and here we have max gas fee over we overrided that function, and you can see that it also includes script gas limit. So max gas is used like max gas describe how much gas your transaction will consume in the worst possible case, like when it will use all script gas limit and all witness limit. And yeah, it's basic difference between max gas and min gas. So, and gas price is defined, pretty simple, like gas multiplied with gas price. So you can find gas to fee function here that accepts gas price, and gas price factor. Yeah, gas price factor, it's something that makes your transaction cheaper. Because we don't burn Ethereum, we don't need to actually charge in the same way as Ethereum does. So yeah, for example, in the testnet currently, gas price factor is 92. So it means that you need to, well, let's say if gas price will be 1 and you consume 1 million gas, it means that 1 million gas will be multiplied by gas price 1 and divided by 92. So your transaction will be cheaper in 92 times in that case. But yeah, if gas price will be 92, then yeah, it will be 1 million in tokens. So yeah, it's how gas price is calculated. yeah, now you know what is minimum gas, what we charge for, how to find values, how much we will charge, etc. Those prices, as I mentioned, are based on benchmarks. In Field Core, we have benchmarks. You also can find folder there if you need to check them. I'm curious, do we have any questions? I think no. Okay. Coming back to sufficient balance. So when we verify your transaction, we verify that we calculate available balance. So we iterate over all inputs. We calculate the total amount available from those inputs. And after we'll subtract, and we have unavailable balance, where unavailable balance is available balance minus max fee. So it's like how much your transaction can consume. And if available balance more than unavailable balance, then everything okay. Your transaction has sufficient funds, at least to cover fee. And also sum of outputs. It is in the case if you want to send some tokens to someone, we also will subtract amount from outputs from available balance. I think that's it regarding gas and how we calculate it. So another aspect will be gas price and how that is calculated. Maybe let's not spend too much time on that. Just I will mention that each transaction may contain tip. So if we will go to, again, transaction definition here, and we need policies. Let's go to types, policies. Where are they? Here. So anyone can attach tip to their transaction. Tip, it is some value, like a value in number of tokens of base asset. It's something like additional what you will pay to block producer. Let's say if your transaction requires 100 fee tokens. If you have tip 1, it means that you will pay additionally 1 token to block producer. Also anyone can specify max fee policy. Max fee, it describes that your transaction can spend more than that max fee. Basically, SDK calculates that value for you by just using max gas that your transaction will consume. And basically that's it. So in most cases, it will be set automatically, but again, you can not set that, but that means that if someone will modify your transaction, like some parts of your transaction that are malleable, then maybe they will charge. You will be charged more for your transaction. So because of that, we will suggest to set max fee to anyone. But again, it depends on use case. And you can see that here is the main difference. For example, in the case of Ethereum, you have max gas limits, like how much your transaction can consume limit. In our case, we have max fee. It is preparation for multi-dimension gas pricing. So currently we charge for execution and for storage in the same way by using gas. But later we plan to split execution gas and storage gas into 2 separate values. And to support backward compatibility, we're already using max fee that will help to achieve that. Because now user need to only specify how much they want to spend instead of how much they want to have limit for everything. Yeah, I think that's it regarding tip and max fee. Maybe I need to mention that currently mempool here it is. Yeah, that before hackathon that issue already will be fixed. Yeah, and mempool will prioritize transaction by based on tip, but not only by tip, also by max gas. So if your transaction consume a lot of gas, you have less but you have the same T as other people, you have less priority than them. So block producer will try to select transactions that requires less work and gives more tip. So yeah, just for the future, because maybe it will be important. And let me briefly mention something regarding gas prices and how they are created. So currently we are using static gas price in testnet, but it will change in 2 weeks and it will be dynamic. The main idea is that gas price, it will be combination of gas for execution. It will be a combination of gas price for execution and DA recording gas price. So because we plan to post all blocks and transaction to DA, that price will be included into gas price used by block producer. So yeah, main idea is that revenue that will be received from DA recording gas price will try to achieve 0 point. And basically, you can treat it as we will burn Ethereum just to post data to Ethereum, because it's something that will be used to post data. And yeah, formula what we are using will try to achieve 0 profit on that gas price. So if we overcharge user for DA, that means that future transaction will be cheaper for users to achieve that 0 profit goal for DA gas price. Execution gas price, DA gas price is based on cost and on reward received for DA gas price. And yeah, the profit it is DA reward minus cost. And yeah, that function will try to minimize profit to do it 0, to make it 0. And execution gas price will rise based on demand. Like the same rule, if block is full, then gas price will increase for 10%, 10 or 12, I don't remember. That PR is on review right now. And the same, if block is not full, it will go down. Yeah, we have a rule that gas price can change, total gas price can change more than for 10 or 12% per block. So yeah, you can predict gas price in next 10 blocks if you want to. But also, because currently definition of how gas price is calculated is not built into protocol. Currently, it is off-chain logic. Like we have a separate service that sends data to GA, and based on information from that service, we decide which gas price will be for next blocks. But later, it will be part of the protocol itself. Like block header will contain all information required to calculate gas price for corresponding block, and everyone will validate them. So yeah, currently that part is off-chain, and maybe because of that, gas price will change a little bit in a different way. Maybe it will be cheaper because we plan to use execution revenue from execution also to cover DA cost, part of that execution. Yeah, and when the change will be publicly available, we also will open specification for gas price. So that information also will be publicly available, and you will see all formulas that are used to calculate gas price. I think that's it regarding gas pricing and estimation of transactions. If you have any question, you can ask them in the somewhere, and I will try to answer them. And now I'm passing green and word to Stasio.
Thank you, Green. That was very informative. Yeah, guys, if you have any questions to the speakers, please write them in the chat. We'll have the Q&A session in the end of the call. So I will read your questions out loud for the fuel team to answer.
Hey, now it's me. Let's go. My one will be a short one, please. We will not take too much longer. But yeah, I think the main idea here, I will start just with the wallets, how you can create wallets on Fuel to interact with the network. We have three ways. One is from the CLI, that is the fork wallet. You can create a fork wallet following these steps here. And in the end, you are going to have like just your accounts like this inside of your terminal. Here we are showing the batch 32 address. Normally when we interact with the chain, I can't see the screen. I can try to stop and try again. Everyone is not seeing. Let me stop and do again. Now it's working.
It works
Yep,
for me, but
I can see it right now, and I could see it before actually. But guys, if you still cannot see the screen, the recording of the event with the screen share will be available, and it will be posted in the Discord soon after our call ends. So
Okay, I will follow that.
don't worry.
Yeah.
Yep.
Okay. Yeah, here it's like like the CLI, you have like a lot of options. You can create new accounts, you can list the accounts that you have. Here you can get the batch 32 address. Normally, when you are interacting with the chain and trying to look to the transactions, you're going to see that we normally use the hex on chain. And then I will show like how you can convert inside of the wallet. But yeah, I think the other wallets that we have will be more visual. That will be the extensions. We have Fuelet, that is one of the wallets from the ecosystem. And we also have the Fuel wallet. That is the wallet that I'm going to show. This wallet here, you can install directly on the web store. I don't need to explain that for you guys, I believe. Also here on this documentation, you can see how the applications like the dApps can integrate with our wallets using the connectors. Maybe something that you guys want to take a look. Also here, I will show the wallet itself and how to use that. Let's just like get a pattern. Let's just unlock this wallet. Yeah, inside of the wallet, you can see your address. You can also like change to the hex address between batch 32 and hex address here. This is how you convert. You can also add other networks. Right now we are using the testnet. That will be the live one for me to show the Explorer also. Inside of the wallets, you can see all your assets here, even the ones that is not added for your account. Any UTXO that you have, it's going to be shown here. And here you can see like all the normal configurations that you can see on other wallets. Like you can have a transaction history, networks management. You can like also see all the connected apps to your wallet. With the address here, we can go to the Explorer. This is the live Explorer that we have for the testnet. You can see all the latest transactions, and you can, when you click to a transaction, you can see like which block this transaction was included. You can also see all the operations, the main operations that the transaction execute. In this case, you can see like it call like a method in the contract on this contract. You can also explore the contract, like see the source code, see the assets that the contract holds, also see like what you are passing to the methods. But if you want to see like, because here we show like a more user-friendly view, you can also go to advanced. That is going to be almost like using the playground directly to the node. and it shows like all the inputs and all the details of the transaction also. And the main thing here is like inputs are like the UTXOs and also the contract states that you are going to be using on the transaction. And also it shows all the outputs of the transaction. You can see the same thing here, but in a more like simple view, more user-friendly. If you go to the playground, you can also do the queries, and this playground is available directly on the node also for you like to play. And then like I can example get a transaction here from my wallet. We get this one. And let me get the contract ID, and let's just put this here. And then you can see like I can take a look on the transaction also. This is useful for debugging because you can get all the fields available on the transaction to verify what happened with the transaction. And also like one thing that you need to be starting looking if you're going to be targeting the live network, it's going to be the faucet. The faucet is also available for you guys to like come here and like be able to get some funds. In this case here, just like normal faucet. And I think that's pretty much it from the things that we have here for exploring the network. And yeah, I said it would be short. Any questions here or anything that I can expand on?
Somebody's typing actually. So let's wait for the question.
Yep.
To be posted. So is there any reason why the Fuel wallet is not on Firefox?
Just time. We didn't have the time to port to Firefox, but we'll in the future probably.
Cool. Thank you. Okay, so maybe we can now pass the presentation to Luiz.
I think for Luiz will be more like Gomez will be more about QA. If you have more questions, then he can help in explaining.
Okay. Actually, guys, I have a question for you. I don't think it was covered through the presentation. So, how can researchers get some tokens to start interacting with the blockchain? And maybe you can share the link to the faucet for a testnet network because, like,
Yeah.
I remember
I
I
was-
was struggling a lot when I was beginning with Web3 security with the faucets and testnet tokens.
Yeah, I'm going to send here on the chat the faucet link. But yeah, you can get the tokens through the faucet. I think this is like the easiest way. You don't need to bridge, you don't need to wait. But you can also go to our portal and do the bridging. And then you would have like, if you have assets on the Sepolia network, you can bridge to the few testnet network. And then you can have the funds there also. This is another way. But normally you can go directly to the faucet here.
Okay, thank you. So let me then ask some questions that Immunefi prepared for you. So Whiteheads can have more like comprehension and technical knowledge about you, about the project. So at first I wanted to ask like, except for the one that were mentioned, are there any prerequisites that researchers might need to start before exploring the Fuel network?
I don't think so. I think it's really simple. Because different from like the EVM chains, you normally need like an indexer to have like transaction history, and on Fuel you can explore the transaction history directly on the node itself. This is true for now. It's probably not going to be like this in the future, but yeah, you can see all the history of transactions directly on the node, and you can query the transactions directly on the playground. But you can also do this visually here, and the only difference is that we limit the number of history transactions that you can see. I can go like only 10 pages deep, and then I can see the transactions. This means that like you don't have like a lot of prerequisites to start looking to the history of transactions. And if you also want to go directly to your account, instead of being looking like to the history of the entire network, let me get anyone here and then change my address here. You can go directly to your account and see like the balances directly on the Explorer also, and see all the transactions that you made.
Cool. Thank you.
Also,
Green, you
fuel gold.
something to add? Well, I mean something to add.
Yeah. Also, like when you go to playground, Luis, could you go to playground, please? Yeah, because it is a GraphQL API, you can always query a documentation, like on the right here, and here you have a list of all supported queries, and yeah, fields that they contain. We try to provide all basic API to receive data, but we don't provide any aggregation queries because yeah, it's something that should be done by indexers. There are several indexer project available in the ecosystem, but yeah, if you don't need any specific, then yeah, here like all data what you need is available, and yeah, it is what is used by wallets or
Yeah.
Cool. Thank you. And there was another question I wanted to ask, like since Immunefi was mostly focused on DeFi and EVM based blockchains and projects built on them, maybe you can quickly highlight the differences between Fuel Network wallets and addresses and Ethereum addresses.
You want to cover this, Green?
maybe use better because you're a consumer of client.
Yeah, no problem. Yeah, the difference here is that we use our addresses are directly like SHA-256 from the public key, and also we use another signature curve, and this is what like Green can explain what it is, just for me to not say something wrong here.
Yeah, let's say like we're using the same curve what is used by Ethereum. So, but like address representation, like in the case of Ethereum, Ethereum takes hash from your public address and takes on the first 20 bytes of that, and it is your address on the Ethereum side. In our case, we don't take any hash and just using we take hash of public key and we just use 32 bytes instead of 20. Yeah, curve what is used is the same just to be compatible with Ethereum. So if you want, you can use, of course, your private address, but yeah, it will generate another your private key, but it will generate another address on the Ethereum network. And if you want to give the same address on the Ethereum network and work with MetaMask, then you need to use predicates, but yeah, it's account abstraction that we support. I think that's it regarding that part. Yeah, maybe Luis,
Okay.
you have some other ideas regarding differences on maybe on development? In development.
No, actually, you
Okay.
said what I really wanted to hear. Also, yeah, thank you, thank you. I think that's it. I don't think that from like the dev side we really need something more. Okay, so I think we can ask our audience if they have any questions. So, guys, please, if you have any questions for the Fuel Network team, please send them to chat. I'll read them out loud so the guys can answer them. Well, it seems nobody's actually typing. So, yep, I wanted to thank you all guys for coming and listening. Thank you to the Fuel team for participating and making this presentation. I bet this will be very useful for our whiteheads. So, yeah, good luck hunting. Don't forget that the Attackathon starts on 17th of June. So happy hunting, guys. If you need if you have any questions, please ask them in on our Discord in a separate channel. And thank you all again. Bye bye.
Thank you all. Bye.
Bye, everyone.